So here we'll be discussing the agenda on equation of first order, equation of first order and higher degree. When you have higher degree, not even first order, we will basically discuss linear equations. Sorry, linear equations of linear equations of higher degree. Let's say not degree, in fact higher orders. Now we know that linear differential equation is an equation where we don't have a multiplication term of the dependent variable and its derivative, right? So if we talk about a general equation of nth order, can be basically written as d ny upon dx raised to n plus p1 times dn minus 1y upon dn minus dx to the power n minus 1 plus p2 times dn minus 2y upon dx to the power n minus 2 and so on. And finally it will be p and y, let us say is equal to x, where p1 p2 p3 are functions of x only, where you can say where p1 p2 p3 are functions of x, right? So and there can be equations, or you can say linear equations, linear differential equations with constant coefficient, with constant coefficient. What do I mean by constant coefficient? Let's say del n y upon dx to the power n plus k1 times dn minus 1y upon dx minus 1 plus k2 times dn minus 2 y upon dx to the power n minus 2 and so on is equals to, let's say, where k1 k2 k3 are constant. So these are very important equations. Sometimes these are not functions of x, these are only constant. These are very much important when we are talking about studies of electromechanical vibrations, electromechanical vibrations. These are equations of the standard forms. I told you in the initial stages also, the differential equations are nothing but physical phenomena, vibrations, electromagnetic waves, flow of fluids. So these are nothing but practical phenomena or physical phenomena which have been converted into differential equations, and we are solving those differential equations. So these types of linear equations of constant coefficient are very much applicable to electromechanical vibrations directly, right? So when we are solving these equations of linear equation of constant coefficient, these are of nth order. So we have n arbitrary constant. Now when we have n arbitrary constant, then we will have different solutions, y1 y2 y3 and so on, right? So we cannot divide the complete solution into single portion. Basically what I'm trying to say is, whenever you are having a linear equation with constant coefficient. With constant coefficient, it will have this thing will have two types of solution. One is called as particular integral, and the other one would be complementary function. If you accumulate these two, this we normally regard as pi and this is normally regarded as ci. If you accumulate both of these, so you will get the complete solution. So the complete solution is nothing but the summation of CF plus PA. Clear? That is what I mean to say. Right? Now let us understand first of all a term called as operator D. We will be using this operator D. What is this operator D? When we are denoting d by dx, d square by dx square, and so on, repeatedly this will be coming. So for our convenience, what we are trying to say is we will replace basically d by dx is equals to capital D. This is just for convenience, right? For example, if I say I have an equation d square y upon dx square plus 2 dy by dx minus 8y. This is a linear equation, is it? Yes, it is a linear equation, and it's a linear equation with constant coefficient. So this can be written as d square plus 2d minus 8 times of y, because we are only saying d by dx is d, not y have to be there, right? So this is how you can solve this particular thing. You can also say that this is nothing but d minus 1, right? And whatever, I mean, if you can bifurcate this into 4 into 2, right, plus 4 minus 2, so it will become d plus 4 and d minus 2, right? So this is how times y. So this is how you can actually use the operator d. Now there are certain rules to find out the complementary function. We want to find complementary function and we want to find particular integral, right? So first of all we have to find out the complementary function. So there are certain rules to find out the complementary function. Now I'm directly giving you the rules how you can find out, right? First what you have to do is you can say rules to find complementary function. First, form an auxiliary equation. Now what is auxiliary equation? Auxiliary equation is nothing but an equation in terms of operator D, right? So auxiliary equation is equation with operator D, right? Then find out the roots of the auxiliary equation. Find the roots of auxiliary equation. Now there are certain conditions now. If the roots are, let's say, m1, m2, m3, and they are all real, then the complementary function. These are roots. And the complementary function will be c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x. Second case, if these are real and you can say different, if the roots m1 m2 are real and equal, then it can be written as c1 plus c2x. So the equation can be written as c1 plus c2x into e raised to m1x, right? You can write m1 m2 whatever, because both are same only, right? Now if supposedly you have pair of imaginary roots, let's say the roots are alpha plus minus iota beta, and there is one real root m3, where m3 is real, then the solution will be or the complementary function will be e raised to alpha x into c1 cos beta x c1 cos beta x plus c2 sin beta x plus c3 e raised to m3x. For real, it will be very simple sort of a thing. Clear? Now we'll solve some examples so that it will become very, very clear to us how we can solve these types of equations. Example could be, find the complementary function of d square y upon dx square minus 2 dy by dx plus y is equals to x e raised to x sin x. You have to find the complementary function. Now let us first convert this into auxiliary equation. So can I say it is d square minus 2d plus 1 y is equals to x e raised to x sin x. This is in function of x. This we know not to get disturbed, right? So solving the auxiliary equation is d square minus 2d plus 1. If I solve this, what will I get? I'll get auxiliary equation. If I solve this, I'll get d minus 1 the whole square. So the complementary function is nothing but c1 plus c2x into e raised to minus 1x, and minus will become plus, right? This is how you can find out the complementary function, right? Supposedly it is given to you find out the complementary function. Find out the complementary function for the equation d square minus 4d plus 3 is equals to 2x e raised to 4x plus cos x. So y, this will be y. So complementary function is not dependent on this function x. It is purely dependent on these values, right? So you have to find complementary function, find CF. So it will be very simple. You will say it is d square minus 4d plus 3 is the auxiliary equation. Solving auxiliary equation, d square minus 3d minus 1d plus 3, d common minus 1 common, d minus 3 is equal to 0. So d is nothing but 1 comma 3. So d is 1 comma 3. So your complementary function, or you can say d is 1 comma 3, or you can say your m1 m2 are 1 and 3. So the complementary function CF is nothing but C1 e raised to x plus C2 e raised to 3x. It's very simple. You can easily solve this particular type of question, right? Problem lies when we have to find out the particular integral. There, let us understand how will we solve the particular integral. Solving particular integral PI. Now, to solve particular integral, let us understand some rules. We'll talk about case 1. You actually want particular integral. So particular integral would be saying that it is of the form 1 by f of d into x. This will be the values of y basically, right? So case 1 is saying when x is equal to e raised to x. Therefore particular integral will be nothing but 1 by f of d e raised to x. Put d is equals to a. Simply put d is equal to a. And condition applied is that if f of a is not equal to 0. But if f of a equal to 0, then particular integral will become 1 upon x 1 upon f dash d into e raised to x. Put here d equal to 0. Sorry, d equal to a. This is a condition where f of a is equal to 0, but f dash of a is not equal to 0. Still, if f dash a is also equal to 0, then the particular integral will become x square upon 1 upon f double dash of d e raised to x, and put d is equals to a. Here you are saying f of a equal to f dash of a equal to 0, and f double dash of a is not equal to 0. And you can go on further also. You can move on. Clear? Similarly, case 2, it is not necessary that x would be in terms of e raised to x only. When x is equal to sin ax plus b or cos ax plus b. Maybe there is a case that b is equal to 0. So sin ax cos bx can be there, right? So particular integral is nothing but 1 upon f of d square sin ax plus b, and put d square is equals to minus a square. Condition applied is f of minus a square should not be equal to 0, because if it is equal to 0 then it becomes a right. So particular integral, now when it is this is equal to 0, then it will become nothing but x times 1 upon f of d square, f dash of d square, sorry, into sin ax plus. I have taken sin, you can take cos also, right? Again put d square is equal to minus a square. Now the condition here is f of minus a square is equal to 0, but f dash of minus a square is not equal to 0, right? And you can further solve this particular thing, right? Right. So if you want to go ahead with particular integrals, you can go ahead. If again f dash of minus a is also 0, then you can go in the third phase, right? Similarly, we'll talk about case 3. Case 3 is saying when x is equal to x raised to some m, where m being a positive integer, right? So in this case, particular integral is nothing but 1 upon fd into xm, or we can say that this is nothing but f of d inverse of xm, right? This can be written as fd into 1 plus 1 by fd inverse into x raised to m, or we can say it is fd into 1 plus x to the power n. Binomial expansion we can use, that is 1 minus fd plus f square d minus f cube d and so on xm. So whatever values you want to find till that particular case, we can easily solve this particular case, right? So let us understand how question can be asked on this particular fundamental. Let's say, for example, find particular integral pi of d square y upon dx square plus dy by dx is equals to x square plus 2x plus 4. Now if you have to find the cumulative function, or sorry, the complementary function, can you find it? Complementary function, more or less it has not been asked, but if you have to find out the complementary function, can you find out? Complementary function will be nothing but d square plus d is equal to 0. So d is common, d plus 1 is equal to 0. So the roots are 0 and minus 1, right? So it becomes c1 e raised to 0 plus c2 e raised to minus x. That will become my complementary function, right? And if you want to find out the particular integral, so particular integral is nothing but, can I say it is 1 upon d into d plus 1 times x square plus 2x plus 4, that is your capital X. So this is in terms of x now. This is in terms of x now, right? So what we can see is x to the power m sort of a thing. So it is 1 by d. Can I write this as d plus 1 to the power minus 1? So it will become 1 minus d plus d square and so on into x square plus 2x plus 4. Now try to understand this thing. This 1 by d I am keeping it as it is. 1 into this whole term. So we'll multiply this whole term, x square plus 2x plus 4, right? Then it is minus times first derivative of this thing. So first derivative minus time will give you 2x plus 2, right? Then you have second derivative. Second derivative, this term will become plus 2x and 2, right? Second derivative. This term would become 0 and this term will also be vanishing. So this will be the type of term, right? If you simplify this, this will become what? 1 by d of x square is only 1x square. 2x minus 2x cancels out, right? Plus 4 minus 2 and plus 2. So it will become plus 4, right? And you have to find the d, 1 by d. That is basically 1 by d is nothing but the integration, we can say, right? So integration, that is nothing but integration of x square plus 4. 1 by d is integrating. We have to counter effect, right? So this is nothing but x cubed by 3 plus 4x. So that will become your particular integral. So the total we can write is also plus c, you can say. So you can say c3. So total we can write it down is complementary function plus particular integral. That will become your answer. Clear? Right? Let us take one more example to understand this particular thing in detail. Let us say an example, find the particular integral of d square y upon dx square plus 4y is equals to sine 2x plus cos 3x. So it is very easy. You can say the auxiliary equation will be d square plus 4, right? So particular integral you wanted directly, it is nothing but 1 upon d square plus 4 times sine 2x plus cos 3x. So now we can say that it is d square plus 4 square, right? So I said it is nothing but, if I put a is equal to 2, you can separate this basically, d square plus 4 into sine 2x plus 1 upon d square plus 4 into cos 3x. Now for the first case, if I put a, that is 2 minus 2 to the square, so that will become 0, f of a minus a square, f of minus a square. So that is why we will have to choose derivative, right? So for the first part, what we'll be saying is it is nothing but x into 1 upon the derivative of auxiliary equation, that is 2d into sine 2x, plus here we can directly substitute minus a square, that is minus 3 square plus 4 of cos 3x, right? So this will be nothing but, now if I put substitute d as minus 2, it will be fine. So now this is nothing but x by 2 of 1 by d sine 2x plus, it will become 1 upon, this is minus 9 plus 4, so it is minus 5 cos 3x. So 1 by d is nothing but integration, you can say. So it is x by 2 integration of sine 2x minus cos 3x by 5. This is nothing but x sine 2x integration will be minus cos 2x. So x into cos 2x by 2 into 2, 4 minus cos 3x by 5. That is your particular integral. Clear? So this is how you will calculate the particular integral. Now sometimes question can be asked on two fundamentals. I mean, we have talked about individually e to the power x. We have talked about individually uh, sin x. Now there could be a possibility where you have something on e to the power x as well as sin x, right? Or x sin x, right? Let us understand how question can be asked on this. Let us solve one question on the mixture of this. Let us say the question is find particular integral of d square y upon dx square minus 4 dy by dx plus y is equals to e to the power 2x into sine 2x. Now try to understand how we will solve this thing, because now you don't have e here, you don't have sine only, we have multiplication of both. So particular integral will become, see, first of all, you need to find out the auxiliary equation. So auxiliary equation will become what? Auxiliary equation is d square minus 4d plus 1, right? So particular integral will be nothing but 1 upon d square minus 4d plus 1 into e raised to 2x into sine 2x, right? So what we can do is, whenever this is a mixture, you'll say that this is nothing but e raised to 2x separate, right, upon 1 upon, you say this is a, let's say, so it is d plus 2 the whole square minus 4 times d plus 2 plus 1 of sine 2x, right? So now it becomes, if we substitute, this is d is minus this, right? So it will be, so if I open the brackets, it will become something like this. Why we have taken this d plus 2 and d plus 2? This is a shortcut which we can directly see, right? We'll be using this as a shortcut. This can be written as e raised to 2x. Why 2? This is a, right? This is a, right? So it is e raised to 2x into sine 2x upon d square minus 3, right? Now if I put d square as minus of a square, minus of a is 4, so this will become e raised to 2x upon minus 2 ka square minus 3 into sine 2x. So then nothing but e raised to 2x sine 2x by minus 7. It is not minus 2 ka square but minus a square, right? So this will become your answer. Clear? So this is how we normally calculate the particular integral. So now this becomes very clear to us how to solve a particular integral, right? So this is basically the types of question which are asked on differential equations. Now you may try different sorts of question based on differential equations, on linear equations, direct equations, complementary function, particular functions, right? Now you will be able to solve all the types of question on this particular topic. Thank you.